All right, let's talk about a term you hear absolutely everywhere these days, machine learning. We're going to pull back the curtain on it. My promise? By the end of this, you'll actually get what it is, how it works, and why it's basically changing everything. So let's just dive right in. I mean, have you ever stopped to think about it? How does your phone just know that's your friend Sarah in a photo? Or how does your email inbox magically swat away all that junk mail? Well, it's not magic, as cool as that would be. It's something even more powerful. We're teaching computers not just to follow a list of instructions, but to actually learn on their own.
And this right here is the fundamental shift, the big idea. See, in old school programming, a person had to sit down and write every single rule. Like, if an email contains this word, it's spam. But come on, what happens when spammers just spell it differently? The rule breaks, right? With machine learning, we completely flip the script. Instead of giving it rules, we give it a mountain of data. Tons of examples of what's spam and what isn't, and we tell the machine, you figure out the rules. It learns to see the patterns and adapt all by itself.
Okay, so what is machine learning, really? And why is everybody and their cousin talking about it now? I mean, the idea has been around for a while, but just recently, a few key things came together and poured a whole bunch of rocket fuel on the fire.
It's honestly the perfect storm. First, we're drowning in data, thanks to the internet. Second, our computers are ridiculously powerful now. And third, the algorithms, the recipes for learning, have gotten so much smarter. You throw in heavy investment from big companies and the rise of cloud computing, and suddenly these super powerful tools are available to just about anyone.
All right, to make this less abstract and a bit more real, let's talk about a problem we all deal with, that never-ending fight against spam emails. It's actually the perfect example to see how a machine really, truly learns. Yeah, you know the type. We've all gotten emails just like this one. And somehow, our inbox just knows. It's like it has a sixth sense for junk. And poof, it's gone. That isn't some poor programmer who wrote a million different if-then rules. Nope, that is a learning system doing its thing.
So there's actually a formal definition for this. A program learns from experience E at some task T if its performance P gets better with more experience. Let's break that down with our spam example. The task T is simple, identify spam. The performance P is how we keep score, the percentage of spam it catches correctly. And the experience E, that's the massive database of emails that you and I have already marked as spam or not spam. The more experience it gets, the better its performance becomes.
Okay, so that's the big picture. But how does a machine actually go from looking at a pile of old emails to making a smart call on a brand new one? Let's walk through the steps. It really all boils down to one thing to get started.
Data. It all starts with data. And not just any data, it has to be labeled data. That means you need a whole bunch of examples where you already know the correct answer. So here, you can see each email is broken down by things we can measure, like where it came from or how long it is, and crucially, each one is already labeled, spam or ham. And yeah, ham is just a funny name we use for a good email, the stuff you actually want to read.
Now, those measurable things, like the country or the length, they have a special name. We call them features. And this is super important. Think of features as the clues or the signals the machine is looking for. The machine isn't reading the email and understanding the meaning of the words. It's just looking for patterns in these numbers. How many people got it? How big is it? Are there certain words that show up a lot? These are the breadcrumbs the machine follows to solve the puzzle. And this basically lays out the entire game plan. Step 1, you gather a ton of that labeled data. Step 2, you pull out or extract all those numerical features we just talked about. Step 3 is where the magic happens. You train a model. This is where the algorithm churns through all that data, hunting for the patterns that connect the features to the final label. And then, step 4, your trained model is ready to go out into the world and classify brand new emails it's never ever seen before.
So really, you can just boil it down to two main phases. There's the training phase. That's like studying for the test. The machine looks at all the examples with the answers. Then there's the prediction phase. That's the actual test. The model uses what it learned to make decisions on new stuff. The cool part is, you do the heavy lifting of training once, and then you can use that smart, trained model over and over again.
But look, this whole idea isn't just for stopping annoying emails, not by a long shot. This exact same process, learning from data, is being used to tackle thousands of problems. So let's zoom out a bit and look at the different flavors of machine learning out there.
First up, we've got supervised learning, and the key word is right there, supervised. It's like a student learning with a teacher.
The data is all neatly labeled with the right answers, so the machine is supervised as it learns. Our spam filter? Classic supervised learning. This is also the workhorse behind a ton of other things, like a bank predicting if you'll default on a loan, a computer classifying if a tumor is cancerous, or your phone recognizing your face. Okay, but what if you don't have any labels? What if all you have is a giant, messy pile of data? That's where unsupervised learning steps in. Here, there's no teacher, no answer key. The goal is just to let the machine loose on the data and see if it can find any hidden patterns or groups all by itself. Think about a supermarket wanting to find different customer groups based on what they buy, or a news website that wants to automatically group thousands of articles into related topics. It's all about finding order in the chaos.
And the third big type is reinforcement learning. Now, this is totally different. This is all about learning by doing, trial and error. You have an agent, which could be a robot or even just a piece of software, and it tries things out in an environment. If it does something good, it gets a reward, like a point. If it does something bad, it gets a penalty. It's literally like training a dog with treats. This is the super powerful idea behind teaching robots how to walk, helping self-driving cars learn to drive, and how AI has gotten so good at complex games that it can beat the best human players in the world.
So whether it's supervised, unsupervised, or reinforcement learning, it turns out that pretty much every machine learning system is built on the same three core ideas, or pillars. And if you understand these three things, you really understand the whole game.
Pillar number 1 is representation. This just answers the question, what does the knowledge the machine learns even look like? Is it going to be a simple straight line, a complicated set of if-then rules like a decision tree, or maybe a complex web like a neural network? This is basically choosing the language the machine is allowed to speak.
Pillar 2 is evaluation. Okay, so the machine has a model, but how do we know if it's any good? You need a way to keep score. It's the scorecard. For the spam filter, our score could just be accuracy. How many did it get right? For a model that picks stocks, the score would be, profit. This score is the crucial compass that tells the machine whether it's getting better or worse.
And finally, pillar number 3, optimization. This is the engine that drives the whole process. It's the active search for the best possible model. The machine tries out tons of different models from its language of representation, and for each one, it checks the score from our evaluation. Optimization is that relentless process of tweaking and searching, all to find the one model that gets the highest possible score. It's the practice makes perfect part of machine learning.
So when you boil it all down, machine learning is really about giving computers a brand new skill, the ability to learn from experience. We've shifted from programming every single step to just providing the data and letting them figure it out. And that leaves us with a pretty huge question to chew on. Now that our machines can learn, what's the next thing we should teach them?